Solving system of equations by substitution when the equations are already in slope-intercept form. So let's see. Systems of equations. They are sets of equations with the same variables, two or more equations graphed in the same coordinate plane. A solution to systems of equations is the ordered pair, if any, where the lines cross. This ordered pair is true for all equations in the system. Now, when you're solving systems of equations by substitutions, if possible, you're going to solve at least one equation for one variable. So usually you want it to be in the y equals mx plus b form. So if it's not in that form, you first need to solve so it is in slope-intercept form. Then you're going to substitute the result into the other equation to replace one of the variables. Okay, so we're first going to have to solve and then we're going to substitute. You'll solve the equation, then you're going to go back and substitute the value you just found into the first equation, or whichever equation is easier to substitute in. Then you will solve for the other variable. Write the solution as an ordered pair. So you'll see on the following examples what I mean by these directions. So let's take a look at the first example. Now, it says step 1, you need to check. Equations are in slope-intercept form. Yep, they both are, so they are ready to be used. You will set the equations equal to each other. So you can see here, since they both equal y, you're going to leave off the y and set these two parts of the equation equal to each other. So negative 3x equals 2x plus 10. You'll move the x term to the left by doing the inverse. Okay, so I subtracted 2x on both sides. You'll have negative 3x minus 2x makes negative 5x equals 10. Then you divide both sides by negative 5, and x will equal negative 2. So there we just solved for the value of x. Now, you're going to rewrite one of the original equations, and I decided to use y equals negative 3x because that's a shorter one. So then you will substitute the value of x, which is x equals negative 2, which we previously solved for, into the equation. So y equals negative 3, parentheses, times negative 2, and when you multiply that, y value is equal to 6. Then you will put the x and y values together to show the solution for the systems of equations. Now remember, the solution is where the lines cross, and so when I put it together, the lines will cross at negative 2, 6. So that is the solution to the equation. So let's look at another example. So now I have these two equations, which I check and they are already in slope-intercept form. Y equals, they're both solved for y equals. I'm going to set the equations equal to each other. So negative 3x minus 4 equals 8. Add 4 to both sides. I'm solving for x. Leaves me with negative 3x equals 12. Divide both sides by negative 3 and x equals negative 4. Now step 3 I skipped because since we already know the value of y, you're just going to put the x and y values together to show the solution for the systems of equations. So the x value we solved for was negative 4. We know from the very beginning that y was equal to just 8. Put it together and you have the solution of negative 4, 8. That's where the two equations, the lines are going to cross. Looking at another example, so now I have these two equations, y equals negative 3x plus 4 and y equals 4x minus 10. They're both in slope-intercept form, so they're good. Now I'm going to set the equations equal to each other, so negative 3x plus 4 and 4x minus 10. I'm going to solve for x. Now move my x term to the left, subtracting 4x. Then I'm going to subtract 4 and get negative 7x equals negative 14. Divide both sides by negative 7, and x value is 2. Now rewrite one of the original equations. Doesn't matter which one you use. I used y equals 4x minus 10. I then substitute the value of x, which in this case is x equals 2 for the x. So y equals 4, parentheses 2 minus 10. Simplify, so y equals 8. 4 times 2 is 8 minus 10, and 8 minus 10 is negative 2. So that now gives me my last step, 4. I'm just going to put my x and y values together to show the solution. X is 2, y is negative 2. So 2 comma negative 2 is my ordered pair for the solution. So now let's look at this last example. First, I check to make sure my equations are in slope-intercept form. They both are. I'm going to take the one part of each equation, set them equal to each other. So 5x plus 9 equals 5x minus 13. Move my x term to the left. So subtract 5x, subtract 5x. When I do that, that leaves me with 0x plus 9 equals 10. And sorry for my mistake here, but then you will subtract 9 on both sides. 10 minus 9 gives you 1. 0x equals 1, but 0 does not equal 1 because 0x equals 0. So 0 cannot equal 1, therefore there is no solution. This systems of equation has no solution because the lines have the same slope. So if you remember from when you did the intro to systems of equations, when they had the same slope but different y-intercepts, they had no solution because they formed parallel lines. This caused the x terms to cancel and the resulting statement to be false. So you can see 0 does not equal 1.